Okay, so the next thing I want to touch on is load order and load order objects and frame rate, what they call FPS, frames per second. Like I say, your target you want to hit for is 60, 50 is fine, 40 is fine. 30 is about minimum. You start getting about 12, 13, 14, 20, you're going to notice some what you consider lag. So let's talk about load order and objects. Let's just say hypothetically I have 100 mods in my game, just 100 mods, 100 plugins in my game. But those plugins do not add any new objects, they only modify existing objects, whether it's an NPC, whether it's something in a workshop object like a wall, a roof, a water pump, whether it's a weapon, gun, armor, it doesn't matter. Crop, it adds no new objects. It only modifies existing objects' data. Technically, the frame rate, now again, we're not talking about changing graphics or anything like that. Everything stays the same, but it's just changing the data that goes with objects. Like the gun might fire faster, might have a different reload speed, things like that. Your frame rate should remain the same with 100 plugins. Now, and the reason being is because there are no new objects being rendered in the game, only the exact same objects. Now remember, we're not adding anything different. We're not taking existing objects and placing them everywhere. We're leaving the game as it is, but we're modifying the specific object's data. Your frame rate's going to be the same because record wise, think of it like records. Each plugin is made up of records. They call them containers, but I'm going to call them records. And inside those records, you have fields. And those fields, like for example, my name, my first name, my last name, and all of that might be fields within a record, like an employee record. Okay? Um, so the record count stays the same, exactly the same. What changes is loading time, the time to get your game up and running, because what the game has to do is take a look at your plugins and supersede some records with others. That's what they call load order. So if let's say an armor value gets changed 5 times, whatever comes last is going to be that armor value's. It's what's going to be. It's what the game's going to use. So think of it sequentially. So the game loads, it loads its base data records, and then it starts applying changes based on a record level, or what they say, it's an it's an IFF file, but it's like an interchange file format, and they call it a container. So it has to apply that, and then it applies the next one, and the next one, and the next one. Now it can do this when a cell is loaded. It can do some in advance. I suspect it does some in advance, and then it loads some as it's needed. This can increase loading times, but not change your FPS because the number of records and objects in the game has stayed exactly the same, but it takes a while to prepare those records for rendering on the screen. Now, if for some reason you add a bunch of new objects, the mods add objects like in this example here, this mod added all of these objects. This, now again, try not to think about the fact that I do have graphic mods in here that change the graphics. I'm talking more of just the fact that there is a mesh which defines how this tape looks and all of that. Now you have more records that the game has to process. So you've increased your loading times again, but now you're going to start affecting rendering times. So your loading times are really not managed, but are affected by how fast your hard drive is, whether it's a 7200 RPM or better, whether it's an SSD, whether that SSD is on a stick, how fast your memory is, because things are loaded from a hard drive into system memory. If you, that's why a lot of times they'll overclock or they'll put the fastest memory possible. And there's a time back in older PCs when memory speed didn't really make that big of a difference. Now that's not the case because the faster the memory, the better. So you have those that you factor in. You have your system, how your system handles the bus speeds. The very basic core working of your motherboard will determine how fast data can be moved, especially if you got a lot going on in the background. Because remember, this game right here is running at the same time Windows and all these other applications are running. So Windows is kind of slicing back. Oops, Windows is kind of slicing back and forth
Okay, hon.
between all of
I
these
have
different
data.
processes that are running,
Be right
including
back.
this game. Now, you also have, so you've got your hard drive,
Of yours.
whether your
Better.
SSD, your loading.
Much,
It's player
much
comments.
better.
Let me pause this so it won't kind of interrupt us. But okay, so you have that. Memory affects it. Your motherboard, the type of motherboard you have affects it. But more importantly, it's your graphic card, your GPU. Can your GPU render all of those extra objects, meshes, shadows? Can it do this? Especially if you're trying to do an EMB, which can be taxing. And I'll explain that a little bit later why it's taxing. But for this one, let's just focus on objects. So now you have more objects. Your GPU has to render more objects, many more objects. So it's working harder. Not only that, your CPU is trying to calculate, it's trying to generate these frames, shadows, things like that. It's trying to do all these mathematical calculations so it can give the GPU what it needs to do its thing. So the game can only offload certain functions to the GPU. The CPU is still required to do some processing. So your frame rate can be tied to how fast you can stream data off the drive. That's why a lot of people go with SSDs because it streams faster. I use one here. I use I've got a stick that I boot from, that I boot my operating system from, but I have just a regular one. It's a regular kind of looks like a hard drive SSD that I install. It's small. It's only like 1 TB, so I only put only the games on there that I really wanna that I really care about. Loading times, streaming times, things like that. You got the speed of your memory. The faster, the better. Motherboard counts. Uh, those things count. But then your GPU is one of the most important things. One of the factors you want to look at in a GPU is how much memory does it have? How much VRAM does it have? The less VRAM you have, when you try to start upping your graphic resolution, that's bigger that's bigger chunks of data that the graphic card has to deal with. And if there's not enough memory in that card to hold all that data at one time, it's going to have to roll things in and out. It's going to have to micromanage that data, and that's going to start slowing things down. Your GPU is going to start going up. You want to look at your GPU. What percentage is your GPU being used? Things like Cyberpunk. If I max Cyberpunk out on my system, my GPU is pushing 100%, and it's cranking about 12 frames a second. There's just no way. If I max everything out, like literally everything. But if I tone it down, it's fine, and I can get 60 frames, 80 frames a second easy, and the game still looks good. So the GPU is important. How many cores processing? How many? They call them different things. I can't think of what they're called right off the bat. Because AMD and NVIDIA calls them, I think they call them CUDA cores, and I forget, AMD calls it something else. But it's rendering cores. It's little sections inside your GPU that handles different things. How many of those do you have? So the more you have, the more expensive the GPU, but the more that GPU can do. And that's one of the reasons I upgraded my GPU to the, I think it's a 6800 XT, or 69, I think it's 6900 XT or something like that. And I'm going to upgrade to the new 7900 here shortly. But that's the reason I upgraded. So that way I could have better graphic resolution, which is easier on my eyes than trying to do like a 1080p monitor. That kind of like just gave me eye strain really bad. But this does not. So that's the reason I went for a bigger monitor. And of course, when I went for a bigger monitor, there's more data being moved because 1920, if you multiply 1920 pixels by 1080 pixels tall, that's much less data to move than if you're talking about 5120 pixels times 1440. That's a much bigger number. You need a more powerful GPU, faster VRAM, faster everything to get that data moved so you can have a good frame rate. So that is what FPS is based on. And the game engine can only do so much. So what you have, and it's going to do so much, so it can't overcome a GPU that can't handle the data. No, 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 I'm talking. You can wait. It's all right, but you're fine. All right, so, if you have a GPU that's too low, you're okay. It's okay. If you have a GPU that's too low, it's not going to be able to handle high-res graphics. You'll have to tone it down. It can't handle. I'll get you something here in just a second. Come on, you want to jump? You can jump. Come on, come on. It's not going to be able to handle too many objects or high-res graphics. So, frame rate, your FPS depends on your GPU, your CPU, memory, motherboard, and all those kind of things. There you go. She's walking across my keyboard now. There you go. Scoot, scoot, scoot. Okay, so that's kind of how that works. That's hardware dependent. And that's dependent. You're okay. It's all right. See? I'll get you something. I gotta hop up here and feed her here in a second. Can't give her too much because if she eats too much, she winds up throwing it up. So I think she kind of swallows her food whole for some reason. Got a sensitive stomach. And I think that's what she wants. Come on. Come on. Okay, so I'm gonna have to cut this short because this cat's definitely gonna be, it's gonna be here. So she's not gonna let me finish this video. So I'm gonna give me a few minutes and I'll come back with another one and explain about objects and all of those things and how you have to try to find a balance between the two. Okay, so let me. God, she's like right in front of the monitor. All right, scoot, little buddy. Come on, scoot, scoot, scoot. Let me in here. You gotta get in here. All right, let me see if I can switch this out. And we're ready.